Hello everyone, I am going to discuss the solution for the second free mock test, and if you are watching on YouTube then you should know the question paper is available on our app. You can download the app from the link given in the description of this video. Download the question. This is the second mock test. First mock test is already over. So if you have not yet subscribed to our YouTube channel, or if you have not taken our free mock test, 5 free mock tests for NEET preparation, the link is given in the description. Go there, register yourself and have the access of the all 5 free mock tests. Okay, so second paper solution I'm going to discuss today. So let's start with the questions. The mechanical quantity which has a dimension of reciprocal of mass m is, okay. Now angular momentum is not reciprocal of mass I omega. Okay, I omega is I is mr square, omega is per second, so it is not per mass inverse. Coefficient of thermal conductivity has nothing to do with mass. Torque is, again, it is force into displacement. It is nothing to do with the mass inverse, so it is gravitational constant. You can check that out dimensionally as well, but we have solved it by the method of elimination. So in case it is, if you think that you know what are the other things which are not valid, you can use the method of elimination. Now let's continue. The position of a particle is given by RT is equal to 4ti cap plus 2t square j cap plus 5k cap, where t is in seconds and r is in meters. Find the magnitude of velocity at t is equal to 1 second. Very easy question. Velocity is nothing but dr by dt. Okay, and at the time t equals to 1 second, right? So we have to differentiate it. Differentiating 4ti, we get 4i cap plus 4t j cap plus 0. This is a constant, so its differentiation will be 0. So we get this as 4i cap plus 4j cap. So what is the magnitude of velocity? Magnitude of velocity is 4 root 2. Square of these two, square root, then square root, so it will be 4 root 2. So if you are wondering, it will be 4 square plus 4 square, that is 4 root 2. Okay, correct answer is option A. Next question. A block of mass 2 kg is placed on an inclined surface AC as shown in the figure. Of coefficient of friction mu, if g is 10 meter per second square, the net force N on the block will be. So here we have a block which is the mu is given 1 by root 3. So first of all you have to take a test. What is the value of tan theta? Okay. If the angle is greater than mu, if tan theta is greater than mu, then the object will move, otherwise object will not move. Why it is important? So tan theta is tan 30 is 1 upon root 3, right? Here theta is 30 degrees. So that means that it is equal to mu. So equal to mu means it is at the angle of repose. Angle of repose means the object will not move. Object will not move means net force on the object is 0. A hospital uses an ultrasonic scanner to locate a tumors in a tissue. The operating frequency of the scanner is 4.2 megahertz. The speed of sound in a tissue is 1.7 kilometer per second. The wavelength of the sound tissue is close to. So we know that frequency is given and velocity is given. What is the relationship between frequency, velocity and wavelength? The relationship is V equals to frequency into lambda, or lambda equals to V by nu. Now what is V over here? V is 1.7. V is 1.7 kilometer per second. Okay, so fortunately it is given in second, but kilometers we have to convert it into meters. So 1700 meter per second. Now put the values over here. So lambda equals to 1700 divided by frequency. It will be frequency, sorry. So frequency means what? Frequency is 4.2. Frequency is 4.2 megahertz, right? Now 4.2 if you put over here, megahertz means 10 to the power of minus 6. Why minus 6? Mega means 10 to the power of 6 in the denominator, but we have shifted it to the numerator and it becomes 10 to the power of minus 6, right? Now let's cancel this. We can assume this number to be 16 and this number to be 4. almost. So it will be 4 4s are 16, so 400 into 10 to the power of minus 6, or it will become 4 into 10 to the power of minus 4. Approximately this is the correct answer. Now let's move on. An ideal gas A and a real gas B have their volumes increased from V2 to V under isothermal conditions. The increase in internal energy, so isothermal condition means temperature is constant. So in constant temperature, internal energy change is 0, no matter ideal gas or real gas, does not matter. So will be 0 in both cases. Next question. A metallic rod of length L is tied to a string of length 2L and made to rotate with the angular speed omega. So you have a metal rod with a length L. Okay, you are rotating it. This length of the string is 2L. Okay, with the free end of the string is fixed on the table. If there is a magnetic field B acting on the vertical direction, the EMF induced across the ends of the rod is. So here you have to do an integration. You have to remember that magnetic field is given by the EMF induced is given by B into V into L, but where V is constant. In case of rotational motion, V is not constant. V changes from point to point. Omega is constant, but V is not constant. Okay, so here what is the V at the extreme end? V at the extreme end, suppose, is V. Angular speed is omega, so V is equal to omega into 3L, right? That is the V at this point. But V will have a different value over here. V here will have omega into 2L. Okay, so you cannot calculate like this. So what you have to do, you have to take you have to integrate it. How to integrate this process? You have to imagine a small portion of dx, okay, and the distance of this is x from the center. Okay, what is the velocity over here? Velocity over here will be equals to V equals to omega into x. Okay, the distance, total distance, we have assumed x. So what will be the force on this small piece? Force on this small piece will be B, which is constant, V is omega x, and into the length is dx over here. The length is dx over here. So this is the force, small force on this small portion. So now we have to integrate this. How to integrate this? Integration will be happening from here to here, that is 2L to 3L. So here the distance from the center is 2L, here the distance from the center is 2L plus L, that is 3L. So 2L to 3L, and obviously B omega x dx. Now this B omega is constant, so it will come out, and you will get inside the integration x dx integration is x square by 2, and you get 2L 3L, right? So it will be B omega 3L square, that is 9L square by 2 minus 2L square 4L square by 2, right? Now you can take the 9 minus 4 is 5L square, so you will get energy as 5 by 2 omega B omega L square. So the answer is 5 by 2 B omega L square. Next, 10 centimeter is a wavelength of light corresponding to the spectrum of 10 centimeter is a very large wavelength, generally microwave or radio wave. From the given option, microwave is more suitable, so 10 centimeter is for microwave. A block of mass 10 kilogram moving in x direction with a constant speed of 10 meter per second is subjected to a retarding force of F is equal to 0.1 x joule per meter. During its travel, the force x equals to 20 to 30 meter, the final kinetic energy will be. So first of all, we will use the work energy principle. What is the work energy principle? Change in kinetic energy will be equals to the work done. Okay, so what is the change in kinetic energy? Change in kinetic energy will be, first of all, calculate the change, then we will add the initial kinetic energy using this. So change in kinetic energy is work done. What is work done? Work done is F dx. Okay, f dx x is from 20 to 30. Why we are using this? Because f is not constant, f is varying with time. So what is f? F is 0.1 x. So 0.1 goes outside, x dx, another x dx integration 20 to 30. Okay, so 0.1 is basically 1 upon 10, nothing else, and x square by 2. So 30 square by 2 minus 20 square by 2. Okay, so I have skipped one step. If you have any doubt, any question, you can check the PDF solution for this. So delta E equals to 1 upon 10. You have to solve it faster. 300 square is 900, 30 square is 900, sorry, 900 by 2 is 450, minus this is 400 divided by 2 is 200. So it will be 450 minus 200, that is 250 divided by 10, that is 25 joules. 25 joules is the change in the kinetic energy. What is the initial kinetic energy? Initial kinetic energy is this is the change in kinetic energy. Initial kinetic energy is half mv square, that is half into 10 into 100. Why 100? Because the initial speed was 10 meter per second, so v square is 10 square, 10 square is 100, so you get this as 500. Now this is the initial kinetic energy, and the force is retarding force. Retarding force means it is opposing the motion, so the final kinetic energy will be 500 minus the change, which is 25, that is 475 joules. Okay, so the answer will be 475 joules. Next question. A body of mass 5 kg under the action of a constant force F equals to Fx I cap plus Fy j cap has velocity at t equals to 0 as u equals to 6 I cap plus 2 j cap meter per second, and at t second v is 6 j cap. The force F is, so you have to find the vector force. So what is the definition of force? Definition of force is basically mass into acceleration. Force is basically mass into acceleration. What is acceleration? Acceleration is final velocity minus initial velocity divided by time, right? V minus u by t. So we can do the same thing using vectors as well. So mass is given 5 kg. So let us put that value over here. And what is the v? V is 6 j cap. And what is u? U is 6 I cap, 2 j cap. Now I am added the negative sign directly. I try to save some time over here. The time taken is 10 seconds. Okay, so here it will cancel, you will get 2 over here. So what is the force acting on this? You get this as minus 6 I cap by 2, that is minus 3 I cap. Okay, 6 minus 2 is 4, so plus 4 divided by 2, that is plus 2 j cap. You can take a little bit extra time if you want, but as you can see, this is the correct answer, but I think some small mistake over here. Next question. When sound waves travel from air to water, which one of the following remains constant? Frequency remains constant. Okay, frequency of a light does not change on changing the medium. Next, the electrostatic potential inside a charged spherical ball is given by V equals to AR square plus B, where R is the distance from the center and AB are constant. Then the charge density inside the ball is. So potential is given AR square plus B, and you are trying to find what is the charge density. Okay. Charge density means rho. Now how to do that? So first of all, what is the formula for V? Formula for V is we cannot use the formula for V. First of all, you have to find the electric field. What is electric field? Electric field is dV by dr. There is a negative sign, but we are not considering the negative sign for now. Electric field is dV by dr. So if you differentiate it, you will get this as 2AR. That is the electric field. Why we are interested in calculating the electric field? Because it is a spherical ball. So Gauss's law, application of Gauss's law will be easier. Now if you consider a radius R portion, okay, and this is the R portion, so from there what is the Gauss's law tells us? Gauss's law tells that whatever the electric field into the surface area, okay, into the surface area equals to the charge enclosed by epsilon naught. So that concept we are going to use. So what is the charge enclosed over here? So basically charge enclosed is nothing but sigma into surface area. So from there we can say that electric field into surface area equals to surface charge density into, so volume charge density here is because it's the potential is changing with distance, you have to use the volume charge density rho into V divided by epsilon naught. Now we have to put the values. What is E? E is 2AR. What is surface area? Surface area is 4 pi r square equals to rho. What is V? V is 4/3 pi r cube divided by epsilon naught. Right, now you can see that r square into r is r cube. So r cube cancels. 4 pi cancels. Okay, and we have so 4 pi cancels. So we have 2a equals to rho by 3 epsilon naught. Okay, or rho equals to 6 epsilon naught a. Okay, 6 epsilon naught a. So correct answer is this. There is a negative sign, as I said, the negative sign we ignored. So that is why there is a negative sign, and negative sign is common across this all the terms. So we are not interested, but magnitude wise it will be 6a epsilon naught. Next question. A particle of mass m1 is moving with a velocity v1 and another particle of mass m2 is moving with a velocity v2. Both of them have the same momentum but different kinetic energies E1 and E2. Then if m1 is greater than m2, what is the relation? So we know that kinetic energy is basically given by p square by 2m. Okay, so kinetic energy is basically inversely proportional to mass. Okay, so E1 by E2 must be equals to M2 by M1. Inversely proportional means they are reversed. The relationship is reversed, right? So what is M2? M2 is greater, M2 is less than M1. Right, so kinetic energy, this must be less than 1, this quantity must be less than 1 because m1 is greater, m2 is small, so E1 must be smaller than E2. Okay, so E1 must be smaller than E2, so option B is correct. Next question. The moment of inertia of a disk about a tangent axis in its plane is, so we have a disk, okay, and we want to find the moment of inertia about the axis parallel to the plane on the tangent and also along the plane. Now for that you need to know what is the moment of inertia along the diameter. Along the diameter passing through the center, the moment of inertia is half of half mr square, that is 1/4 mr square. Okay, now this distance is r, so you have to add 1/4 mr square to two parallel axes. This is called parallel axis theorem. Okay, mr square plus only mr square, so it will be 4 plus 1 5 by 4 mr square. So correct answer is 5 by 4 mr square. Correct answer is option C. Next question. A 1 kg object strikes a wall with velocity 1 meter per second at an angle 60 degree. Okay, 1 kg object hitting a wall at an angle 60 degrees with the wall, 60 degree with the wall. Very, very important. And then it reflects back. it reflects in the same angle. If it is in contact with the wall for 0.1 second, if it is in the contact with 0.1 second, then what is the force exerted by the wall? So first of all, you have to find what is the change in the momentum. So momentum initially was in this direction. Okay, these components will be cancelled. These components will cancel because they are in the opposite direction. Okay, so final momentum was in this direction. Initial momentum was in this direction. Final momentum will be in this direction. The change in momentum will be, if you see, this is theta, so this component will be sine theta component. So the change in momentum will be 2 mv sine 60. Okay, 2 into, this is always, whenever there is a, you have to remember that when the ball is striking a wall at some angle, the change in momentum will be 2 mv sine theta. If this angle is given, it will be cos theta if that angle is given. Okay, but it will be always 2 mv, and if it is hitting the wall directly, then after hitting it will be just 2 mv. Okay, so mass is given as 1 kg, velocity is given 1 meter per second, and sine 60 is √3/2. So the change in momentum is √3. Now what is the force? Force is change in momentum divided by change in the time. So time of contact was 0.1 second, so it will be √3 divided by 0.1, that is 10√3. So the answer will be 10√3 Newton. Next question. Monochromatic light of frequency 6 into 10 to the power of 14 Hz is produced by a laser. The power emitted is 2 into 10 to the power of -3 watt. The number of photons emitted on the average by the source per second is. So what is the energy of one single photon? So first we have to find what is the energy of a single photon, that is h nu. Now if n number of photons are emitted, if n number of photons, what is the total energy? N into E1, right? And that number of photons, if it is emitted per second, if the time is also given per second, then that is nothing but power. Okay, power is energy per unit time. So if n number of photons are emitted per second, then power is any, or power divided by E1 will give you the number of photons. So now everything is known. Power is given 2 into 10 to the power. So what is the photon? So it is given 2 into 10 to the power of -3. Okay, what is energy? Energy is h nu. H is 6.6 into 10 to the power of -34. And what is nu? Nu is 6 into 10 to the power of 14. Okay, so you will get this as 36, almost 36, slightly more than 36, almost 40. 6 6 is 36, it will be 39 point something. So we take it as 40 and 10 to the power of -20. We have on top 2 into 10 to the power of -3. So we can cancel it. We get 20 over here. So we get this as 10 to the power of 17 divided by 20. Or if we take 100 out of this and divide it by 20 and we keep it as 10 to the power of 15, then we get this as 5 into 10 to the power of 15. So the correct answer is 5 into 10 to the power of 15. Next question. 3 straight parallel current carrying wire are shown in the figure. The net force experienced by the middle conductor of length 25 centimeter. So here you can see in the equation, the current through this is 30 ampere, current through this is 10 ampere, current through this is 20 ampere. Now let's see what are all the forces. Because the current are in opposite direction, so it will experience a force in this direction. So we are saying this force is F right. This is the right side force. We will calculate Fr first. What is Fr? Fr is nothing but mu naught by 2 pi I1 I2 by the distance into the length. Okay, so mu naught by 2 pi is 2 into 10 to the power of -7. Mu naught is 4 pi into 10 to the power of -7. So divided by 2 pi you will get 2 into 10 to the power of -7. What is I1? I1 is 30. What is I2? I2 is 10. What is the distance? Distance is 3 centimeter. 3 centimeter means 3 into 10 to the power of minus 2. Okay. What is the length? Length is given 25 centimeters. So 25 into 10 to the power of minus 2. So this minus 2 cancels, and you get this as this 3 cancels. You get 10 over here. So 100 and 25 into 2 is 50. So 50 you get 100. 3 zeros you will less. So 5 into 10 to the power of minus 4. This is the force on the right side. Okay, slowly solve it. Don't need to hurry. Multiplication calculation part you have to learn it on your own. I cannot teach you calculation. Only thing I can teach you how to shorten the calculations, how to do it smartly. But multiplication part, 10 to the power part, that you have to do it on your own. Next is force on the left. So now this wire again, they are in the opposite direction, so the force on this side will be force on the left, and that will be due to this wire. This wire is giving force right, this wire is giving force left. Okay, now we have to calculate what is the force on the left. Same formula. Okay, force left, everything is same, and since we have calculated it once, it will be easier for us. 2 into 10 to the power of minus 7 into multiply 20 into 10, that is 200, divided by, on the division the distance will be 5, and on the top will be 25. So 10 to the power of minus 2 I have not written because they will cancel anyway. So 5 5s are 25. Now it will be 5 2s are 10, 10 into 200, 2000 means 2 into 10 to the power of minus 4. So which force is greater? So right side force is greater. So what is the net force? Net force will be force right minus force left, right? Because FR is right greater. So 5 minus 2 is 3, and 10 to the power of minus 4 will be common. So the force is 3 into 10 to the power of 4 towards the right. Next question. The xt graph for a particle performing simple harmonic motion is shown in the figure. The acceleration of the particle at time t equals to 2 seconds is. So if you see this graph carefully, you will see that the amplitude of the graph is 1. Okay, and at 2 seconds the particle is exactly at its maximum position. That is, it is exactly at its maximum position. So what is the acceleration? Acceleration will be omega square into a. Okay, so you have to find the value of omega square. Obviously negative. There is a acceleration is usually negative. So omega square into a, and a is positive. So if a was negative, that negative could have cancelled, but because a is positive over here, acceleration will be negative over here. But you have to calculate omega. How to calculate omega? If you see the entire graph, so this is the point where the graph ends, right? So that means this is the time period. This is the time period of the graph. Time period is 8 seconds. Now what is the relationship between time period and omega? So you remember in the AC chapter, if you have remember, omega is equal to 2 pi into f, and f is basically 1 upon t. So this is 2 pi by t, or t is basically 2 pi by omega. If you remember it, very fine. If you don't remember, you can remember it like this. More you practice, you will remember these formulas easily. So t is equal to 2 pi by omega, or omega equals to 2 pi by t. Whatever you want to use. So we are using this formula. So omega will be 2 pi by the time period is 8. So it is the omega. Now we will apply this formula. So a equals to minus, it is omega square x, right? Acceleration is omega square into x. That was the definition, that was the condition for simple harmonic motion. So omega square is 4 pi square. Now we can cancel it, okay? Obviously pi by 4. Let's simplify it so that we don't have to do a lot of mathematics. So here it will be pi square by 16 into a. A is what? A is 1. So the answer of the acceleration is minus pi square by 16. So correct answer is option C. Next question. The pressure P of an ideal gas and its mean translational kinetic energy per unit, the value is 2e by 3. If you want to check the derivation, it is given in the PDF. I am not doing, it's very easy, common from NCERT, so that's why I am not doing the derivation. A metal sample carrying a current along the x-axis with the current density Jx ampere per meter square is subjected to a magnetic field Bz Tesla along z-axis. The electric field Ey is Newton per coulomb developed along the y-axis directly proportional to Jx as well as Bz. The constant of proportionality. So what is the meaning of that? First, Ey, that is the electric field, is directly proportional to the current density Jx. Also, it is directly proportional to the magnetic field Bz. So A is proportional to B, A is proportional to C. So A must be equals to, you can write this as Ey is equal to constant into Jx By, right? Now we have to find what is the dimension of this constant K. So K will be equals to electric field divided by Jx By, right? Bz, sorry, Ey. Now what is the unit of electric field? Electric field is Newton per coulomb. What is Jx? Jx is current density. Current density's unit is ampere meter to the power minus 2. What is By? So if you forget what is By is, you can remember that the force, magnetic force, is basically B into V into L. Okay, so this is the magnetic force. From there you can find the sorry, not BVL, BIL, right? Bil sin theta. So magnetic force on a current carrying wire is given by BIL. From there you can calculate the magnetic unit of magnetic force, Tesla basically. Tesla is nothing but Newton divided by ampere meter. Okay, so many students sometimes confused about it. So it is Newton by ampere meter. Okay, so ampere is cancelled over here, and this is minus 1, so it will go up and it will become Newton per coulomb meter to the power minus 3 into Newton. Okay, so this coulomb will come down, so Newton by coulomb meter to the power minus 3 into Newton. So this Newton cancels. Now this goes up, meter to the power 3 into divided by coulomb. Now what is coulomb? Coulomb is charge, that is equals to current into time. So coulomb's unit is ampere second. So most students don't often remember. So coulomb is ampere second, so it will be minus 1, second minus 1. So the correct answer is this one. Very interesting question. Next, the distance traveled by a body moving along a straight line in time t is proportional to t cube, the acceleration of the particle, acceleration time graph of the particle. So let's see, the displacement is given by t cube. So dx by dt is 3t square, or d2x by dt square is 6t. So that is the acceleration. Acceleration is directly proportional to time, so it will be a straight line, right? So straight line means acceleration versus time graph, it will be this graph. Okay, only one straight line is given. This one is constant. Constant is not possible. Okay, so here as you can see that acceleration is directly proportional to time, so it will be a straight line. It can actually it should pass through the origin, but there may be some constant involved as well. We don't know, that's why this is the possible graph. Next, which one of the following statement is false? A vector has only magnitude, whereas the scalar has both magnitude and direction. So first statement itself is false. Vector has magnitude as well as direction, but scalar has only magnitude. So we are not looking further. You can check the other options as well. A motor car is traveling at 30 meter per second on a circular road of radius 500 meter. It is increasing its speed at the rate of 2 meter per second. Then the acceleration of the car at that instant. So here we have a particle moving in a circular path. So here we have two components. One is tangential component of acceleration, another one is radial component of acceleration. Okay, so rate of change of speed is basically the tangential component of acceleration, that is 2. We have to calculate the radial component of acceleration. For that, we know that radial component is according to the centripetal acceleration, v square by r. So what is v square? V square is 30 square means 900, and r is 500 meter. So this is the AR. Now we have to find what is the net acceleration. Net acceleration is square root of AT square plus AR square. That is square root of 81 by 25 plus 4. That is 81 plus 25 into 400 divided by 25. Okay, so it will be square root of 181 by 25. Now if you see the option, so it will be 5, 1 upon 5 and 181. What is the value of 181? We have to find a closest number squareable to 181 which can be squared, right? So it can be let's say 116 will not come. So the closest number to 181 that is squareable is 169, okay, which is slightly smaller, 12 smaller. So it will be, you can consider this equals to 13 by 5, which is equals to 2.6. Okay, so this is the closest number. So this is the closest answer you get. All the answers are far apart, so you can easily identify which one is correct. 2.7 is the correct answer. Next, how many electrons make up a charge of magnitude 20 microcoulomb? 20 microcoulomb means 20 into 10 to the power of minus 6. Now you have to remember one simple fact that one coulomb charge gives you about 6.6 into 10 to the power of 18 number of electrons. Okay, so one coulomb gives you 6.625, but I am approximating this number of electrons. So this is the number of electrons present in 1 coulomb charge. So any factor, anything any other charge they will give you, you have to multiply this factor. This is the easiest solution. Otherwise you have to do the calculation 1.6 into 10 to the minus 19, divide this by 1.6 into 10 to the minus 19, and you have to calculate it. Okay, so what will be the answer? So 6.6 into 20 is about 13.2 into 10 to the power of 132. 132 into 10 to the power of 12, or 1.32 into 10 to the power of 14. Okay, so closest answer will be this one. Okay, if you put the exact value, you will get this one is as the answer. Next question. If M, Az, Mp, Mn denote the masses of the nucleus A, Xz, proton and neutron respectively in units of U, and Be represents the bonding energy in MeV, then which of the following is correct? So we know that binding energy per c square is basically mass defect. Basically this is the expression for mass defect, that is mass of proton into number of protons plus number of neutron into mass of neutron, okay, minus the actual mass. But if you see that none of the single option is actually correct, so answer will be none of these. Ideally this should be negative, then it would have been a correct answer. Now next question. A charged particle Q is placed at the center of a cube of length L, A, B, C, D, F, G, H. Another same charge Q is placed at the distance L from O along the line parallel to AB as shown. Okay, then the electric flux through the face BCGF. What is the electric flux through this surface? Now if you consider this only this surface, now remember that Gauss law is not applicable over here. First of all, you have to understand that. Why? Because BCGF is not a closed surface. Yes, entire cube is a closed surface, but BCGF is not a closed surface. Okay, this distance and this distance are equal, so whatever flux is outward due to this charge, the same flux will be inward due to this charge. So they will cancel each other. The net flux through this surface will be 0. The net flux will be 0. Okay, if you consider the entire cube, then it will be q by epsilon naught. Okay, the entire surface. But if you consider only a single surface, it can be 0. Very, very interesting question. A body is projected from ground at an angle of 30 degree with the horizontal with a speed of 30 meter per second. Okay, what is the angle of its velocity vector with the horizontal after 1.5 seconds. So initially it is projected like this. What is the component of x component? X component is v cos theta or u cos theta. Basically this is u cos theta. So that is cos 30 is half, so it will be 30 divided by 30 into half, that is 15 meter per second. Okay, this is the component of x component. What is the y component? Initially y component is u sin 30, is one mistake, cos 30 is root 3 by 2. Cos 30 is root 3 by 2 and sin 30 is half. So it will be root 3 by 2, it will be 15 root 3. Okay, now what is u sin 30? U sin 30 is half, so 30 into half, that is 15. This is the initial speed. Now if you know about projectile motion, the x component remains unchanged, only the y component changes. So what is the y component after 1.5 second? Okay, y component after 1.5 second, vy equals to uy, this is uy, minus gt, right? Gravitational acceleration is only acting along the y direction, not along the x direction. So that's why uy minus gt. So what is uy? Uy is 15, minus g is 10, time is 1.5, so it will be 0. Okay, so velocity along y direction will be 0. So if velocity along y direction is 0, that means the particle is at the highest point, that is along this point. So what is the angle now? Angle along horizontal will be 0. Angle with the horizontal itself will be 0. So correct answer is 0. Otherwise what would have we done? We could have done it, but tan theta equals to Vy by Vx. Okay, you can use this formula as well. Vy is 0, so 0 by 15 root 3, or theta is equals to 0. So if tan theta is 0, that means theta is 0. Next, a fully charged capacitor C with initial charge Q0 is connected to a coil of self-inductance L at t equals to 0. The time at which the energy stored equally between the electric and magnetic field. So this is the portion from which the question was asked is out of syllabus. It may be included in the NEET syllabus. I need to check it once, but the LC oscillator is not part of the syllabus. So this is the answer for this question. You might check it if LC oscillator is part of NEET syllabus or not. If it is not, then you can skip this question. Of the various series of the hydrogen spectrum, the one which lies wholly in the ultraviolet region is Lyman series. Okay, Lyman series, Lyman series, whatever you say. The combination of gates shown below yields. So what is the combination? So it is a NAND gate, right? So A and A coming in, and NAND gate will give you A bar. Similarly, B and B coming in, it will give you B bar. Now what is A bar and B bar is coming in, so it will be A bar into B bar whole bar. So that is from the Boolean algebra, it will be A double bar plus B double bar, that is A plus B. Okay, so it is an OR gate. The answer is OR gate. Plus means OR, and means multiplication. An artificial satellite moving in a circular orbit around the Earth has a total energy, kinetic plus potential, is E naught. Its potential energy will be 2 E naught. Okay, kinetic energy generally, kinetic energy is basically equals to total energy magnitude wise, and is half of the potential energy. Okay, so any one of them, if you know, you can calculate the other half. Sign of the potential energy is negative, sign of kinetic energy is positive. Velocity versus displacement graph of a particle moving in a straight line is given by this graph. Okay, corresponding acceleration versus velocity graph, very important. It is acceleration versus velocity graph. So this is velocity, this is displacement. How can you convert it? So there is an easy way to do it. What is acceleration? Acceleration is velocity by time. What is velocity? Velocity is displacement by time. So if you divide it by time, okay, if you divide this by time, so graph will remain the same because you are dividing it with the same value along x and y axis. So it will become A versus V graph. So the correct answer will be same, that is option C. Okay, interesting question. There is another method given in the PDF solution. You can check that out as well. Next question, a primary cell has an EMF of 1.5 volt. When short circuited, it gives a current of 3 ampere. Then the internal resistance is EMF divided by the short circuit resistance. So EMF is 1.5 divided by short circuit resistance 0.3, that is 0.5 ohm. So 0.5 ohm is the answer. The magnetic lines of force inside a bar magnet is from south pole to north pole. Okay, so it is from south pole to north pole. Outside it is north to south, from inside it is south to north. A straight rod of length L extends from x equals to A to x equals to A plus L. Find the gravitational force it exerts on a point of mass m kept at x equals to 0 if the linear density of the rod is mu equals to A plus x bx square. This is slightly difficult for NEET level. The correct answer is this. The detailed solution is given in the PDF. You can check that out, but I will not recommend this question. This is slightly tricky, more appropriate for JEE mains exam. If Q and E and W are denote respectively the heat added, change in internal energy and the work done in a closed cyclic process. Okay, closed cyclic process means internal energy will be 0, no question asked, everything else will remain. Everything else can change, but energy, total internal energy change will be 0. A shunt resistance of 1 ohm is connected across a galvanometer of 120 ohm resistance. A current of 5.5 ampere gives the full scale deflection of the galvanometer. The current that will give the full scale deflection in the absence of the shunt nearly. So what is the meaning of that? Suppose we have a galvanometer, we have a shunt resistance. Okay, the current which giving the full scale deflection is this. But that not entire current is passing through the galvanometer. Only a small portion of current is passing through the galvanometer, that is Ig. Okay, in the absence of the shunt, this much current will give the full scale deflection. This is the maximum current that can pass through the galvanometer, maximum galvanometer current, and in the absence of shunt, that current is sufficient for full scale deflection. So what is the current through the shunt? Current through the shunt is 5.5 minus Ig. Okay, now the potential across shunt and galvanometer are same, so we can write 120 into Ig, that is the galvanometer potential, and that is equals to 5.5 minus Ig into 1, that is the shunt potential. Okay, now you have to simplify this, that is this minus Ig will come to this side, so 121 Ig equals to 5.5, or Ig equals to 5.5 divided by 121, that is, if you cancel it with 11, 0.5 and 11, 0.5 into 11 is 5.5. Now you can take this as 0.5 divided by 10, which is equals to 0.05 ampere. So the correct answer is 0.045 ampere, because we have reduced the 11 to 10, so that is why our answer is slightly more, but correct answer is 0.045. A steel wire of length 20 cm and uniform cross section 1 mm square is tied rigidly to both the ends. The temperature of the wire is altered from 40 degrees Celsius to 20 degrees Celsius. The thermal coefficient of the linear expansion is alpha equals to 1.1 into 10 to the power of minus 5, and for steel it is 2 into 10 to the power of 11 Newton per meter square. The change change in the tension of the wire. So change in the tension of the wire is given by y into area into so what is the formula? First let's check. Y into area into alpha into delta t. Right, this is the simplest formula. If you remember it, it will help you a lot. So y is given here 2 into 10 to the power of 11. Area is given as 1 millimeter square. 1 millimeter square means 10 to the power of minus 6. Millimeter is 10 to the power of minus 3. Millimeter square is 10 to the power of minus 6. What is alpha? Alpha is given by 1.1 into 10 to the power of minus 5. And what is the change in temperature? Change in temperature is 20 degrees. Okay, 40 minus 20. I hope you understood. So for 40 into 1.1 into 10 to the power of plus 11 minus 11. So everything is 0. So you get this as 44. Okay, 44 is the answer. 44 Newton is the answer. Next question. To produce an instantaneous displacement current of 2 milliampere, the space between the parallel plate capacitor of capacitance 4 microfarad. The rate of change of applied variable potential difference must be. So you have to find, you have to know that the capacitance is Q equals to C into V. Okay. Now current is, what is current? Current is dq by dt. That is C into dV by dt. Okay, so what is the current given here? Current given is 2 milliampere. That is the displacement current. This is the displacement current, right? Change in the charge in the capacitor. So we have to find what is the dV dt is. So ID is 2 milliampere. That is 2 into 10 to the power of minus 3 divided by C. C is 4 microfarad. 4 into 10 to the power of minus 6. That will be equals to dV by dt. Okay, we have taken this C and divided over here. Right, so we get this as 2, and you will get this will go up 10 to the power of 3. So 1000 divided by 2 equals to dV by dt, or dV by dt equals to 500. Okay, so this is the 500 is the answer. Next question. A boat is sent across a river with a velocity of 8 km per hour. So we have a river, boat is sent across the river with a 8 meter per second. Okay, if the resultant velocity of the boat is 10 km per hour, then the velocity of the river. So suppose the velocity of the river is, let me use this direction. Suppose the velocity of the river is VR. Okay, then what is the resultant velocity? Resultant velocity will be r. So from the Pythagoras theorem or from the vector theorem, whatever you say, r square is equals to velocity of the river square plus velocity of the boat square, or velocity of the river square equals to r square minus velocity of the boat square. Now r is 10 km per hour. Okay, and this is 8 km per hour. I made a mistake. It will be 8 km per hour. Okay, so it will be r square is 10 km per hour, that is 100, 10 square is 100, and 8 square is 64, so it will be 36. Now you have to take the square root, so VR equals to 6. So correct answer is 6 km per hour. Next question. In a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at the frequency of 2 into 10 to the power of 10 Hz and amplitude 48 volt per meter. Then the amplitude of the oscillating magnetic field is, the speed is, speed of light in sound is in free space is given. So what you have to remember is that speed of light is basically amplitude of the electric field divided by amplitude of the magnetic field. You don't need to use the frequency at all. Frequency is not required. So magnetic field amplitude is equal to E naught by C. Okay, so E naught is given 48 divided by 3 into 10 to the power of 8. 3 16s of 48, so it will be 16 into 10 to the power of minus 8. So 16 into 10 to the power of minus 8. Now if you see, all the options are given 1.6, so it will be 1.6 into 10 to the power of minus 7. So correct answer option B. Next question. Yellow light is used in a single slit diffraction experiment of slit width of 0.6 millimeter. If yellow light is replaced by X-rays, then the observed pattern will reveal. Now you have to understand that 6 millimeter is a very high length compared to either you consider yellow light or you consider X-ray. X-rays have a nanometer length, wavelength, right? For nanometer, 0.6 millimeter will appear to be more than a kilometer long. So to observe diffraction or interference, the slit width should be comparable to the wavelength of the light. Okay, so because you are using X-ray having 1 nanometer wavelength, okay, and the slit width is 0.6 millimeter, you will not observe any diffraction because the slit width is very large, so no diffraction will be observable. Next question. When a ray of light enters a glass from air, so glass from air, we already know that in one of the other question we checked that wavelength, frequency remains same, and because it is entering glass from air, so the speed of light is decreasing. Air has the highest speed, so speed of light is decreasing means V is equal to nu into lambda. Now nu is constant, V is decreasing, that means lambda will be decreasing, so the wavelength decreases. So the correct answer is option A. An ideal fluid flows, laminar flow, through a pipe of non-uniform diameter. The maximum and minimum diameter of the pipe are 6.4 centimeter and 4.8 centimeter respectively. The ratio of minimum and maximum velocities of the fluid. Now we know that in case of laminar flow, A1 V1 equals to A2 V2. Okay, A is the area. Now area is, what is area? Area is basically pi d square by pi d by 2 whole square, right? This is the formula. So basically area is directly proportional to diameter ka square. Okay, so that for the knowledge we will use. So V, what we have to find? Ratio of minimum to the maximum. Now when we will have the minimum velocity? Minimum velocity we will have when the diameter is maximum, that is area is maximum. Okay, and maximum velocity we will have when the diameter is minimum. Okay, so V min by V max will be equals to area min by area max. Okay, so area mean means diameter also mean, and it will be d max square, right? Area proportional to diameter square. Now what is d mean? D mean is 4.8, so 4.8. What is d max? 6.4 and whole square. Now decimal goes out, so we get 4, and this will be 3. 3 16s are 48, 4 16s are 64. So the answer will be 9 by 16. So correct answer is 9 by 16. Next question. Two identical strings X and Z made of same material have tension Tx and Tz in them respectively. If their fundamental frequencies are 450 Hz and 300 Hz respectively, then the ratio of Tx by Tz. So what is the frequency? Frequency is basically 1 by 12 square root of T by mu. Mu is the mass per unit length. Okay, so suppose this is for Tx. Okay, so Tx is basically proportional to frequency square. Okay, so Tx by Tz is frequency x square divided by frequency y square. Okay, what is the frequency x? Frequency x is 450, so it will be 450 into 450 divided by 300 into 300. 0 0 cancels, 0 0 cancels. 3 15s are 45, 10, so it will be again 15 and 10, so 15 15s are 225 divided by 10 10s are 100, so it will be 2.25. The calculation speed you have to learn, you have to practice. I have practiced a lot, that's why my calculation speed is better. You have to practice a lot to improve your calculation speed. If you think that sir is doing the calculation too fast, you have to learn that. Calculation has only practice. Okay, calculation, there are some tricks. It is simply cancellation and multiplication, so nothing I have done. Next question. Last question, a particle is moving 5 times fast as an electron. The ratio of the de Broglie wavelength of the particle to that of the electron is 1.8 into 78 10 to the power of minus 4. The mass of the particle is close to. So first of all, what is the formula for de Broglie wavelength? It is h by p or h by mb. Okay, so what is the wavelength of the particle? Wavelength of the particle is h divided by mass of the particle times 5v. What is 5v? 5v is the velocity of the electron. What is the wavelength of the electron? Wavelength of the electron is h by mass of electron into v, right? The particle is moving 5 times fast as electron, right? So that will be the wavelength. Now the ratio of their, okay, particle to the electron is 1.8. So particle by electron is 1.878 into 10 to the power of minus 4. Okay, or if you divide this, obviously h will cancel, and particle, in case of particle this will go up, so we get mass of electron divided by 5 into mass of the particle is equals to 1.878 into 10 to the power of minus 4. So we get from here as mass of the particle is equals to, so this one will multiply over here and the entire thing will divide over here. So mass of electron is 9.1 into 10 to the power of minus 31 divided by 5 into 1.8. Ten to the power of minus 4. Now 5 into 1.8 is almost close to 9. So 9 and 9.1 they will cancel. We get this as very close to 10 to the power of minus 27. Okay, or we can write this as 10 into 10 to the power of minus 28. Okay, we have multiplied with 10 and 10 to the power of minus 28. So if you see the answer, the correct answer is obviously this one. This is one very close to 10. Okay, so if you do the exact calculation, the value will be slightly less than 10. That's why I have written it like this. So the correct answer is 9.7 into 10 to the power of minus 28. Don't fall for the trap. Don't mark this as correct answer. Okay, so anyway, this is the closest answer that you will get, and this is the correct answer as well. And if you have not yet subscribed to our NEET campus channel, don't forget to subscribe to our channel. Also, if you have not downloaded the app through which you are getting the question papers, you have to download the question paper. I'll be back with the solution for part 3. Till then, bye.